Hello everyone, welcome to Vishesh Educational Videos. In this video, I am explaining the deadlock avoidance. Deadlock avoidance is like taking the medicine before suffering from the disease. So in deadlock avoidance, there are two types. So first one is resource allocation graph algorithm and second one is a banker's algorithm. So in this video, I am explaining the first technique, resource allocation graph algorithm. Right? So if you want to use a resource allocation graph algorithm, then your resource type should be having only single instance. If you have multiple instances of a resource type, then you can't use resource allocation graph algorithm. You have to go for a banker's algorithm. So now, what is the single instances of a resource type? So single instances of a resource type means, if you consider your resource as a printer, then you should have only one printer. Suppose if your resource is a hard disk, then you should have only one hard disk. So if there is only single instances of the resource type, then only you can use resource allocation graph algorithm. Otherwise you can't use resource allocation graph algorithm if you have multiple instances. Right? In multiple instances means you can have more number of printers, 3 to 4 printers, 5 to 6 hard disks, like that. Then you have to use banker's algorithm. So this resource allocation graph algorithm is only for the resource type that is having a single instance. Right? So before understanding what is a resource allocation graph algorithm, how you are going to use a resource allocation graph algorithm to avoid the deadlock, you need to understand what is a safe state and an unsafe state. I can say a state is a safe state if the system can allocate the resources to each process in some order and still avoid a deadlock. So in simple words, you should avoid a deadlock. Even if you allocate the resources to the process, it should not result in the deadlock. You should allocate the resources in such a way that deadlock should not be there. Then I can call it as a safe state. Getting, guys? So if deadlock is there in the system, then I can call it as an unsafe state. If deadlock is not there, then I can call it as a safe state. You can see here. So if deadlock is there, then it is an unsafe state. I can tell that the system is in the unsafe state if a deadlock is there. If deadlock is not there, obviously I can tell that the system is in the safe state. Just remember this. A system is in a safe state if no deadlock is there. A system is in unsafe state if deadlock is present. Getting, guys? Now I will explain the resource allocation graph algorithm. So to explain the resource allocation graph algorithm, I am taking this example. So you can see here, if the resource type contains a single instance, then we use resource allocation graph. I already told you that. So the resource type should contain a single instance, then only we have to use resource allocation graph. So this is my example. Right? By taking this example, I am going to explain the resource allocation graph algorithm. Now you can see here. So here I am going to use 3 types of edges. So claim edge, requested, assignment edge. Right? So you can see here. So there I am used different types of edges in this diagram here. So what are those edges means? Claim edge, request edge, assignment edge. Now I will take up the each edge and I will explain. So what is a claim edge? Claim edge means the process may request for the resource in future. The process may request for the resource in future. You can see here. Here this is the claim edge. Claim edge is indicated by dotted dashed arrows. You can see. Right? Claim edge means the process may request for the resource in the future. You can see here. Here P2 may request for the resource R2 in the future, because I have a dashed line. P2 may request for the resource R2 in the future, that is claim edge. It may request for the resource R2 in the future. In the same way, P1 may request for the resource R2 in the future. because I have claim edge here, right? So P1 may request for the resource R2 in the future. It may request. I can't guarantee that it will request, but it may request. Then I can call this edge as a claim edge. Getting, guys? Now, what is the request edge? You can see the notations here, right? So request edge means whenever a process wants to use a resource, it can use a request edge. Very simple. If any process wants to use a resource, it can use a request edge. You can see here. So here P2 is requesting the resource R1. P2 is requesting the resource R1. You can see the notation. PA is requesting the resource RJ. So this is the request edge. Request edge means whenever a process wants to use a resource, it can use a request edge. Now, what is the assignment edge? What is the assignment edge? Assignment edge means if a resource is free, suppose when a process requests a resource using a request edge, if a resource is free, then the operating system allocates corresponding resource to the process. It is going to assign the resource to the particular process. If it is free, then I can call it as assignment edge. You can see here, this is the assignment edge. R1 is assigned to process P1. R1 is assigned to process P1. So if a resource is free, then it can allocate that resource to the particular process. Here R1 is free, that's why it allocated the R1 to the process P1. It assigned the R1 to the P1. Getting, guys? So in this graph I used 3 types of edges. So claim edge, request edge, assignment edge. Claim edge means the process may request for the resource in the future. Request edge means whenever a process wants to use a resource, it can use a request edge. Simple words, it can request the resource. If a resource is free, then operating system allocates the resource to the process, right? Then it is called as a assignment edge. And one more important thing, remember this. Once the execution of the process is completed, then the process releases the resource, right? Obviously, once the execution of the process is completed, the process releases the resource. Again that edge, again the assignment edge is converted to what edge? Claim edge only. Again the assignment edge is converted into claim edge. For example, see here. So when a resource R1 is freed, when a resource R1 is freed, this assignment edge can be converted into again claim edge only. Getting, guys? Understood? Suppose if you have any doubts, please post your doubts in the comment section. Next, now you know what are the 3 different types of edges we used in the resource allocation graph algorithm. So now I will take up this example. I will explain, right, how the operating system is going to avoid the deadlock, right? So in this example you can see here, very simple example, I already told you. Here P1 may request for R2 in the future, because P1 may request for R2 in the future, this is a claim edge, you can see. And again in the same way P2 may also request for R2 in the future, that's why I have a claim edge. Getting, guys? Now P1 is holding the resource R1, you can see P1 is holding the resource R1, that's why it's the assignment edge. Getting, guys? P1 is holding the resource R1, then that's why it's the assignment edge. Now P2 is requesting R1, you can see P2 is requesting R1, then it's a request edge. P2 is requesting R1, then it's a request edge. Here one thing you have to know for sure here, before allocating the resource, here P2 is requesting the R1, right? P2 is requesting the R1. In the same way P2 may request R2 also. So here before allocating any resource, the OS should check for any possibilities of deadlock. So simply the OS can't allocate the resources to every process. No, it's not possible. It may result in the deadlock. That's why OS should check for any possibilities of the deadlock. Now we will see. If deadlock is there, then it is an unsafe state. Definitely you know that. I already told you. Suppose if a deadlock is there, then it is an unsafe state. If deadlock is not there, it is a safe state. So OS should check in such a way that deadlock should not happen if it allocates the resources. OS should allocate the resources to the process in such a way that deadlock should not happen and the state should be in a safe state. Getting, guys? So it is the responsibility of the OS. Internally it should take the decision whether to allocate the resource to a particular process or not. It should check whether allocating the process may lead to deadlock or not, like that. Based on that only it should take the decision, right? See, here processes needs to be executed in safe sequence. That is very important. You should avoid the deadlock. You should allocate the resources in such a way that it may not lead to the deadlock. Here process needs to be executed in a safe state. Now what we will do means, we will take this example, we will check whether it is possible to allocate the resources to the process in such a way that deadlock may not happen. We will check that now. See, this is the example. So you can see here, so P1 is may request for R2, P2 may also request for R2 in the future. It is a claim merge. P2 is holding the P2 is requesting the R1 and R1 is holded by the P1. You know that. Now, so you know that how many claim edges are there here? 2 claim edges. So P2 may request for R2. Now assume that R2 is free. Assume that R2 is free. So R2 is free, right? OS may allocate R2 to the P2. You can see. So assume that R2 is free. You can see this claim edge is converted into the right assignment edge. R2 is assigned to P2. R2 is assigned to P2. Claim edge is converted into the assignment edge. That means R2 is free. That's why I allocated R2 to P2. Now next, see here. Next, if P1 request for R2 now, if P1 request for R2 now, definitely it may lead to the deadlock. So OS can't allocate R2 to P2. Why I am telling this means, see, if R2 is allocated to P2, yes, here you can see R2 is allocated to P2. When R2 is allocated to P2, chances are there P1 may request R2 also. P1 may request R2 also. So when P1 requested R2, this claim edge is converted into which edge? Request edge. You can observe here. The edge between P1 and R2 is converted into request edge. Why? P1 is requesting R2. Right? Don't get confused, guys. First, what happened? P2 requested for R2. Assume that R2 is free. So OS what it did? It allocated R2 to P2. You can see. At the same time, now if P1 requests for R2, this claim edge is converted into assignment edge. So see, this is not possible. It will result in a deadlock. You can see, if a cycle is there in the graph, what it means? Deadlock is there. You can see. Now when you allocate R2 to P2, then at the same time if P1 is requesting R2, see, it will lead to the deadlock. It will lead to the deadlock. So that's why operating system should decide whether to allocate R2 to P2. So if it allocates R2 to P2, then the chances are there at the same time P1 may request R2. If P1 requests R2, then definitely it will result in deadlock. Right? That's why. Now what is the solution here? That's why, see here, although R2 is currently free, we cannot allocate it to P2. Why? You have seen that if you allocate R2 to P2, chances are there P1 may request R2, that may lead to the deadlock. That's why, although R2 is, OS should take a decision properly. Although R2 is currently free, we cannot allocate it to P2 since the action will create a cycle in the graph. It can't allocate, it can't do that. You have seen that. This is a cycle. So it leads to deadlock. So what it should do? So operating system should wait until it gets sufficient resources. Once the operating system gets the sufficient resources, it can allocate to the particular process. Here operating system should wait. It should not move from safe state to unsafe state. It should be in a safe state. So what is the solution here? So operating system should wait. It must wait until it gets sufficient resources. Once it gets the sufficient resources, it may allocate the resources to the process. So you can see here, in this way I can avoid the deadlock. I can avoid the deadlock using the resource allocation graph. Using the resource allocation graph, I can avoid the deadlock. Right, guys? So if you have any doubts, please post your doubts in the comment section. Thank you for watching the video.